Hey, welcome back. We're going to try our hand at balancing some nuclear reactions. I think this is one of my favorite parts of the course, actually, and it goes something like this. So imagine you've got alpha decay, and how do you know if it's alpha decay? Well, basically, I'll just tell you it's alpha decay. You have to kind of look them up. Some atoms undergo a, maybe 90% alpha decay, maybe 8% beta, and 2% gamma. So in the problem, I'll tell you what kind of decay it is. But in alpha decay, essentially, the atom loses an alpha particle. So the atoms lose 2 protons and 2 neutrons from the nucleus. So for example, if we take something like uranium-238 undergoes quite a bit of alpha decay. Uranium's the 92nd element, so there's the 92 down there. And if we go ahead and write alpha decay over the arrow, it tells us basically what's going to happen. And what is an alpha particle? An alpha particle is something that has 2 protons and 2 neutrons. We said that that corresponds to helium. The mass number, right, goes at the top. So 2 and 2 make 4. So we'll write a 4 up top. And the number at the bottom is the atomic number, the number of protons, so 2 goes below. I said earlier it's actually charged, but there's so much energy given off here, we're not going to worry about keeping track of the charge, to be honest. You could write them if you wanted to. And the interesting thing then is, what is this element X? That is the daughter particle, right? So what is the daughter of this decay process? And we can figure it out actually by balancing the equations as follows. So we look at the mass number at top, it's 238. And we know that that corresponds to the number of protons and neutrons. And if we lose 4 in total, then presumably the daughter atom has got 4 minus 238. So that is how many? Yep, 234. Now, if you've lost 2 protons, then if you started with 92 and now you've lost 2, presumably you've only got 90 remaining. So we're seeing we're just balancing here. So when we write the alpha particle numbers here, basically we add these 2 numbers together to get this number, and we add these 2 numbers together to get this number here. So if you like this, just the difference between these and these. Now, what is element X? And so if we look at my handy dandy or our handy dandy periodic table, then all we've got to do is look for the element with a atomic number of 90. And on my periodic table, that element is TH. That's actually thorium. But if you don't know it's thorium, that's no problem whatsoever. So I'm just going to go ahead and erase this if I can. Yep, there we go. The X goes, and I'm going to replace it with thorium. So uranium-238 undergoes alpha decay and makes thorium and an alpha particle. All right, you ready for some to try? So here are 3 chemical equations. I'm sorry, nuclear equations I'd like you to balance. So radon-222 undergoes alpha decay, and so does americium-241, and so does astatine-210. And I'd like for you to go ahead and write out the products of this nuclear chemical equation. So go ahead and pause the video and write it out, and I'll give you a hint here in a couple of minutes if you're stuck. Okay, so the hint is the alpha particle in all of these is essentially just a helium nucleus. So you have to remember that alpha particles are just helium nuclei. And so you can write all of these down. So go ahead and pause the video and go ahead and see what you get for the remainders. All right, so if you've unpaused, what do we have here? So the top number is 222, and if the alpha particle can carry 4 protons and neutrons, then what you have left must have 4 fewer. So 222 minus 4 is 218. And if you look at the bottom number, that is 86 here, 86 protons. 2 have gone away, so we must have 84 protons remaining. And if we look at the element on our periodic table, I've got a little microscopic periodic table in my hand here, and I'm squinting to try and read the numbers, and 84 is PO, which is polonium, named after the country Poland. We took a look at americium. So americium is actually found in smoke detectors, and in smoke detectors, they produce these alpha particles, and when smoke appears, it blocks the alpha particles and it shuts off an electrical current, and the smoke detector basically alarms. So it's got 241 protons and neutrons, 4 are lost, so that leaves you with 237 remaining. 95 protons at the bottom, 2 have gone away, so that leaves us with 93. And if we look at element number 93 on our periodic table, it is NP. That is neptunium. If we look at astatine, we can do the same thing. The top number, right, must be 206, because 206 plus 4 gives you 210. The bottom number, right, must be 83, because 83 plus 2 is 85. And if we look on our periodic table and we look at what element is 83, 83 is Bi, and Bi is bismuth, and that's the element you find in Pepto-Bismol to make your tummy, if it's upset, to make it much better. So you are now awesome, right? If you can do these kind of things in your sleep, then you're going to do very well on the final exam whenever you see a nuclear reaction. And I think they're kind of fun, don't you?